All right. So this is going to be the second part of our lesson from yesterday. So we're still solving square root and cube root functions, or radical functions, if you will, radical equations. So our next example, I just want to, before we start, we're down at the bottom of page 21 in your notes. So our next example has fractional exponents. So you'll look, if you look at example 5 and example 6, we have fractional exponents. So we're going to just kind of talk through the steps. So step number 1, if you have one radical in the problem, isolate it to one side. If you have two radicals, put one on each side. We already know that. Use the opposite power to remove the radicals. So I want to just show you what that means. That means that if you have a cube root, right? Remember, this is the same thing. Like if you have the cube root of x, remember this is the same thing as x to the 1/3 power, right? So the opposite of that, right, is going to be to cube it. So if we want to get rid of a cube root, we have to cube it. If we want to get rid of a square root, we have to square it. And whatever you do on one side, you do to the other. The thing that's weird is when you have a fractional power, like maybe you have the exponent of 4/3. Well, to remove that, you have to use the reciprocal power. You have to use the reciprocal power. So the reciprocal of 4/3 is 3/4. So I want to talk to you about this root. Whenever you have a square root or a fourth root or a sixth root or an eighth root, any even root, you need to think about putting the plus and the minus, right? And here's what I mean by that. Let's look at the fourth root of 16. Well, the fourth root of 16, that's 2. That's the same thing as 2 to the fourth power, but it can also be negative 2 to the fourth power. So when you have an even root, you have both a plus and a minus, a positive and a negative factor, a positive and a negative. So we're going to use reciprocal powers to remove the fractional exponent, but I want you to remember this plus or minus. This is when your denominator is going to be an even number. Then you solve the resulting equation, possibly by factoring. Check your answers. Remember, you cannot have extraneous solutions. A square root does not equal a negative number. Okay? So we're going to start right in with our first example. So our first example, 2x to the 3/4 power minus 7 equals 9. Well, I feel like you guys do a little bit better when I write it as a radical. Maybe that's not true. I'm not even going to do that. Let's start all over again. So first thing I want to do is draw my river, and we're going to get we're trying to isolate the radical or the fractional exponent. So I want to add 7 to both sides. I want to add 7 to both sides. So that gives me 2 times x to the 3/4 power equals 16. 2 times x to the 3/4 power equals 16. Well, the only thing that's being raised to a power is the x. So that's my radical term. So I can still divide both sides by 2. So now I have x to the 3/4 power equals, well, 16 divided by 2 is 8. Now I need to use the reciprocal power to remove the fractional exponent. So the reciprocal of 3/4 is 4/3. So I have to take this to the 4/3 power. So that gives me x equals, and I'm going to write this as a radical function so you can see it. So this is the third root of 8. We're going to take our answer and we're going to take it to the 4th power. So what is the third root of 8? Well, the third root of 8 is 2, and 2 to the 4th power is 16. So here in this example, x equals 16. Now you have to remember we need to check that, right? So I want to check this, and I always check it into the original equation. So I have 2 times, x is now 16. So 16 to the 3/4 power minus 7 equals 9. Well, what does 16 to the 3/4 power look like? Well, that's really the fourth root of 16, and then we're going to take that and cube it. Minus 7 equals 9. So that's 2 times, well, what is the fourth root of 16? Well, the fourth root of 16 is 2, and I have to cube that. Minus 7 equals 9. Well, what is 2 cubed? Well, 2 cubed is 8. So I really have 2 times 8 minus 7 equals 9. Well, what is 2 times 8? 2 times 8 is 16. 16 minus 7 does, in fact, equal 9. Okay? So this answer is good. It is not an extraneous root. And we talked yesterday about extraneous roots. Extraneous roots are introduced by various algebraic methods that, for one reason or another, create a non-valid solution to the equation. So these roots are called extraneous, right? And we checked that yesterday. We found some extraneous roots. So let's look at this next example. So in our next example, I have x to the 2/3 plus 9 equals 18. So the first thing I want to do is get my radical term or my fractional exponent all by itself, right? So I'm going to subtract 9. So that gives me x to the 2/3 powers equals 9. 18 minus 9 is 9. So now I have to multiply by the reciprocal power. Well, the reciprocal power of 2/3 is 3/2. The reciprocal power of 2/3 is 3/2. So I have x equals, so look, this has a square. This has an even denominator, even root. That means it's a square root. So my final answer is going to be plus or minus. I need to know what the square root of 9 is, and then once I get that answer, I'm going to cube it. Well, the square root of 9 is 3, and 3 cubed is 27. So my answer is x equals plus or minus 27. Well, we have to check both of those. We have to check and see if x equals 27 works, and we have to see if check and see if x equals negative 27 works. So if x is 27, I have 27 to the 2/3 power plus 9 equals 18. Well, the third root of 27 is 3, and 3 squared plus 9 is 18. Well, 3 squared is 9. 9 plus 9 is 18. So this one works. Now let's check negative 27. So let's see. When x equals negative 27, well, that's negative 27. Remember, you always put a negative into a parenthesis. To the 2/3 power plus 9 equals 18. Well, the third root of negative 27 is negative 3. And negative 3 squared is a positive 9. And 9 plus 9 does equal 18. So the answer of negative 27 works also. So two answers. Okay. So if you were to put this into, like, if you were doing a delta math activity, you would have x equals 27 and x equals negative 27. Okay. All right. Let's move on to page 22. We have 4 more examples. All right. My screen's all weird. Okay. So number 7. So remember, we want to isolate the radical. So the first thing I need to do is divide both sides by 3. I'm going to divide both sides by 3. So that gives me x plus 5, the quantity to the 2/3 power equals 9. All right. So I want to get rid of this radical, right? Or this fractional root, if you will, or this fractional exponent. So I'm going to multiply by its reciprocal power, which is 3/2. But that means I have to do 3/2 on the other side. So the left side, your radical kind of, these cross out, or you get 6/6, which is 1. So the parenthesis melts away, and I just have x plus 5 equals. Well, again, this is a square root. So this is the square root of 9 to the power of 3. But remember, because it's a square, we have both a positive and a negative. So x plus 5, well, we just did the square root of 9 to the power of 3. The square root of 9 is 3, and 3 to the third power is 27. So that means that you have either x plus 5 equals positive 27, and x plus 5, you have both, not or really, and x plus 5 equals negative 27. So subtract 5 from both sides. So x could be 22. Subtract 5 from both sides, or x could be negative 32. Now we need to check. We need to check both of those. So let's check x equals 22. So when x is 22, I have 3 times, parenthesis, 22 plus 5 to the 2/3 power equals 27. Well, 22 plus 5 is 27. And the 2/3 power is 27 to the 2/3 power. Well, that's the third root of 27. And the third root of 27 is 3. So I really have 3 times 3, the quantity squared. But what is 3 squared? Well, 3 squared is 9, and 3 times 9 is 27. So this works. X equals 22 is a good answer. So now let's check x equals negative 32. Let's see if that one works. So I have 3 times negative 32 plus 5 to the 2/3 power equals 27. Well, negative 32 plus 5 is negative 27. And so to the 2/3 power. But the cube root of negative 27, well, that's negative 3. So I have negative 3 squared is 27. Well, negative 3 squared is 9. So 3 times 9 equals 27. And that is true. So this also works. So I have two solutions. I have x equals 22. That's a good solution. And I have x equals negative 32. That's also a good solution. Okay. You guys are doing great. Let's go to the next one. So for this example, the first thing I want to do is add 3 to both sides. Remember, I'm trying to always isolate the radical or the rational exponent. So that gives me 4 times the quantity, x minus 7, to the power of 2/5, and that equals 16. Next, I'm going to divide both sides by 4. That gives me x minus 7 to the 2/5 power equals 4. So now I want to multiply by the reciprocal power. Well, the reciprocal power of 2/5 is 5/2. 5/2. Uh-oh. Look, we're taking a square root. So I know that my answer is going to be plus or minus the square root of 4. And then I'm going to take that to the 5th power. And on the left side, I just have x minus 7. So let's see. X minus 7 equals plus or minus. Well, the square root of 4 is 2, and 2 to the 5th power is 32. So x minus 7 equals the positive 32, and x minus 7 equals the negative 32. Add 7 to both sides. So x equals 39. Add 7, and x equals negative 25. All right, we have to check both. We have to check them both. So let's check the first one. So we're going to check x equals 39. So I have 4 times the quantity, 39 minus 7 to the 2/5 power minus 3 equals 13. Well, let's see, 39 minus 7 is 32. So I have 4 times 32 to the 2/5 power minus 3 equals 13. Well, I need the 5th root of 32, and the 5th root of 32 is 2, and 2 squared is 4, minus 3 equals 13. 4 times 4 is 16. 16 minus 3 is 13, and 13 does in fact equal 13. So x equals 39 works. Let's check and see if x equals negative 25 works. So 4 times negative 25 minus 7 to the 2/5 power minus 3 equals 13. Well, negative 25 and negative 7 give me a negative 32. Negative 32 to the 2/5 power minus 3 equals 13. Well, we know that the fifth root of 32 is 2, so the fifth root of negative 32 is going to be negative 2. So I have 4 times negative 2 squared. Well, negative 2 squared is just a positive 4. So I really have 4 times 4 minus 3 equals 13. 4 times 4 is 16, minus 3 is 13. So both of my answers work. Both solutions are correct. Okay, let's go on to example number 9. Example number 9, I have the square root of 5x minus 11 equals the square root of 2x plus 16. I want to use the opposite of the square root. The opposite of a square root is to square something. So I need to square both sides to eliminate those radicals. When I square both sides, I have 5x minus 11 equals 2x plus 16. I am going to subtract 2x from both sides, and I'm also going to add 11 to both sides. So let's see, 5x minus 2x is 3x, negative 11, positive 11 cancel out, positive 2x, negative 2x cancel out, 16 plus 11 is 27. Divide both sides by 3, and x equals negative 9. So now I need to check. Let's see, 5 times negative 9 minus 11 underneath the radical must be equal to the square root of 2 times negative 9 plus 16. Let's see, so 5 times negative 9, well, that's negative 45, minus 11 equals, let's see, the square root of 2 times negative 9, that's negative 18, plus 16. So I actually end up with negative 45 and negative 11 is negative 56. So I have the square root of negative 56 equals the square root of negative 2. Is that true? No, that is not true. This is not true. That means that there is no solution. So this is extraneous. X equals negative 9. Did I say x equals negative 9? Ding, dang, dong it. Now, if we were in class and not me making a video, I would have caught that. X is positive 9. All right, strike that, rewind. X equals positive 9. So when I do the check, I have the square root of 5 times 9, which we know is 45, minus 11 equals the square root of 2 times 9, which is 18, plus 16. 45 minus 11, well, that's 34. So I have the square root of 34, and 18 plus 16 is the square root of 34. So does this work? Yes. Sorry. So this is good. X equals 9. Whew, that was crazy. Alrighty. So this next one, remember we read in the directions, step number 1 said, if you have two radicals in the problem, put one on each side of the equal sign. So I need to move this over to the right side. So I'm going to do that by adding the cube root of x to both sides. I'm going to add the cube root of x to both sides. And when I do that, I have the cube root of 3x plus 7 equals the cube root of x. So I want to get rid of that cube root. So I'm going to cube both sides. And when I do that, I have 3x plus 7 equals x. I'm going to subtract 7 from both sides, and I'm also going to subtract x from both sides. 3x minus 1x is 2x. Positive 7, negative 7 cancel out. Positive x, negative x cancel out. 2x equals negative 7. Divide both sides by 2. X equals negative 7 halves. Okay, so now we are going to check our answer. So let's do the check. So when I check, remember I put that back into the original equation. So the cube root of 3 times negative 7 halves plus 7 minus the cube root of negative 7 halves equals 0. Well, let's see. 3 times negative 7 is negative 21. So I have negative 21 over 2. And I'm going to rewrite that plus 7 as a 14 halves. Plus 14 halves minus the cube root of negative 7 over 2 equals 0. Well, negative 21 plus 14 is negative 7. So I actually have the cube root of negative 7 over 2 minus the cube root of negative 7 over 2 equals 0. And that is true. So this is your correct answer. Alrighty. So let's talk about homework. So yesterday we did all of the square roots equations just because we hadn't finished our notes, right? So this was yesterday's assignment. So today, your 3.4 assignment, we're really going to focus on the cubic roots. So you guys are going to do numbers 2 and 3. Those are both cubic roots. 5 and 8. And then if you flip it over to the next side, you are also going to do 11a and b and 12 a. I will make 12b plus 3 extra credit. I will make 12b plus 3 extra credit, but you have to remember to check your solutions. So you're going to check for extraneous solutions, especially on the ones on the back side. Okay. And you have to, for the extra credit, you have to show all your work. And if you want the extra credit, it has to be ready for me to check tomorrow. That's Friday at the beginning of class. Alrighty, that's it.